Hello, everyone. Welcome to another episode of the Data Standard Audio Experience. Today we have Iftah Gideoni, the CTO at Forder, and today we're speaking about fraud detection patterns. So, welcome to the show, Iftah. I'm very excited to have you today.
Many thanks for having me.
Yeah, and could you go ahead and just tell us about yourself and introduce yourself to the audience?
Sure, I didn't start as a data scientist. I actually started with the ITers in the Air Force and then started studying physics. But during my master's in the University of British Columbia in Vancouver, in Canada, I took a course of measurement theory, and this course changed the rest of my career. I started to work on inference and decisions under uncertainty, and that's what I'm doing since. In the post-master's research, I did work on deliberation of agent under uncertainty, and in each and every company since then, I led the research and implementation of the systems that would infer and decide where we cannot be sure, right? And only in companies where this is the core value that the company delivers. In the last 7 years, I do it for Forder, which is a leading fraud detection and decisioning company for e-commerce.
Yeah, so super interesting stuff that you're working on right now and in your past work. And how do you use data science and analytics to detect fraud?
What is interesting is that fraud detection did not start with particular data science techniques. It was mainly using sets of rules. And these sets of rules, there is a particular country and we will not allow transactions from this country when using particular credit card unless it is less than $60 and unless the person can prove that they have some past transactions and so on. And when you start building these sets of rules, they become unmanageable. Then you start using data science. First, you collect all the input points that you have and start to build the tagging and apply supervised techniques, starting with the basic techniques of further regressions and then into trees and so on. What you find then is that it's not enough. And it's not enough because the assumption of stationary data sets is not always true. It is true for most of the cases, but not for the most interesting ones. And the human story is so convoluted, say, in comparison to the amount of data that we have, and given the very imbalanced classes of our data, that it is very hard to infer and have enough having the catch rate good enough without insulting too many people by declining their transactions. So we need to combine the analytics with the machine learning in order to create an inference machine that can detect and stop fraud while allowing most of the legitimate people do their purchases with as small a friction as possible.
Yeah, definitely. And great insight there. And how are you kind of ensuring that the patterns you're looking for actually exist within the data sets that you're working with?
The patterns exist most of the patterns exist in the data sets. And using these patterns, it is easy for us to catch all the kids that are trying to steal pizzas from pizza delivery companies. But the most interesting pattern are not necessarily exhibit themselves in the data set. And why is that? For two main reasons. First, as said before, our classes are very imbalanced. The amount of false negative, that is the fraud that we approved, is less than 0.1%. Of every 1,000 transactions that we approve, only one is illegitimate because we are able to stop most of the fraud. On the other hand, those transactions that we detect as fraudulent, we decline them, and then they never ship. And if the transaction didn't happen, we would never know whether it was indeed a fraudulent transaction or it was a legitimate person that we insulted. Now, this is one reason why not all patterns actually exhibit themselves in the data sets. The other reason is, and here we slide into game theory, the other reason is that our adversary is an intelligent one. And the ability of the fraudsters to change behavior according to what happened and what Forter did and what the fraud detection system did is done in a much faster cycle than our ability to change our model. So not all patterns are exhibiting themselves in the training sets, and we need to cover for that with continuous analytical rosters of looking at the data, looking at the latest signals that we have from the outside world, and changing our Bayesian chains that are coming on top of the models. So most of the patterns, or are there, or put it differently, all the stupid fraudsters, we can catch them simply by the machine learning systems. The sophisticated fraudsters that act and react according to what our system is doing are posing a bigger problem. And there we need the actual fraud researcher to add logic and add their wisdom into Bayesian chains that are coming above the a machine learning that is based on only on the data in the training set.
Yeah, definitely. And there's a lot of different moving parts to fraud analytics and just detecting it and being able to think about steps ahead before fraud actually occurs is so important, and it's always going to be changing. So I think it's an area that uses data science that is, you're always quick on your feet to be able to detect this. But it's super interesting stuff that you're working on. And what are some things that you look for when making these inferences about similarities between people and fraud patterns?
That's a very important question. Why is it so important? Because in the last 4 or 5 years, the fraud ecosystem crystallized to a degree where sophisticated fraud is more common than in the past. And what I mean by sophisticated fraud is fraud that can exhibit transactions that by themselves, the single transaction cannot be distinguished either by an experienced analyst or by the machine learning, cannot be distinguished from a legitimate transaction. The only way we can then detect that this is a fraudster is by our ability to connect this event, these transactions in front of us, to personas that we saw in the past. And persona in the past is the collection of activities and transactions that were made in the past. Now, what is important there is that all these simple cases where, okay, these two has the same email and or the same phone number and or the same address of shipment and or the same credit card or the same account, all these are less interesting. The interesting parts are those of the fraudsters that are trying to exhibit a totally new persona that will make it very hard for us to connect to previous activities that we already have in our system. And we, for example, Fodder now has 1.3 billion personas in its systems. We know most of the people that act online in the US, most of the IPs, most of the addresses, most of the devices, and most of the phones in the US, and can categorize them. But most important is what you do about the new persona that you cannot connect. And then we are trying to connect these through similar behaviors, through similar patterns and modes of operations. And overall, we have more than 150 attributes in each vector that we are trying to connect. Think about a very non-orthogonal space. It's non-continuous. You cannot derive. And think about creating distance measures on these spaces. And we need to apply and measure this distance measure to set this distance measure over 1 billion times for each transaction in real time, and then find the probability that this transaction is the same person that we saw in the past. Now, we do this measurement of distances, which is a real-time clustering. We do temporal anomaly detection, that is whether particular behavior is repeating itself. And I'll give an example here. Say you have a store in New York, and say you have a credit card from the Netherlands, a Dutch credit card. And say you have the transaction executed from Namibia in Africa. Now, this is pretty rare, but it's not unheard of, right? Every week we have, among the very many millions of transactions, we have several such occurrences. Now, if suddenly we have a rate which is 10x the rate of this combination, then the normal rate, it does indicate similarity. It does increase the chance that these are actually the same people, and these transactions having all the same source. Well, not always, because the easy part here is to detect that there is a spike in the data. The harder part is to tell that this spike in the data actually tells that this is the same person. Even harder is to look at how you take this spike of, which is a tuple of several items that were similar among them, and make it so and insert it to the system in a way that is immune to mutations that a fraudster will try to do in order to circumvent this similarity that you found. So we are working on, we are using both matching and clustering of many small and hidden attributes. We are working on unsupervised temporal anomaly detection to find similarities. And we always measure the propensity of the person to hide. Because when the person is trying harder to hide, we are trying to be more sensitive and to allow our system to detect it nevertheless. For example, a legitimate person, a persona that we know to be legitimate, will not try to change too many things. Well, usually it will be either the device or the phone number or the credit card or the address. Two or more of these attributes will stay the same. While with fraudsters, we know that they'll try to change all of them.
Yeah, definitely. And that's something that's I'm sure that you and your team have had to analyze for a while now to really be able to solidify the differentiation between um people and these fraud patterns that are occurring, definitely. And we know that especially for fraud detection, it's so important for data to not be static when training your data also. And so how are these data sets updated constantly? And is there kind of a streamline of data going?
This is very interesting, and I think that from 2016, where we actually started to analyze this question, we made a lot of changes that made our data store look different. And we find that when you get the data structures right, you actually make your life much easier. And the first question that we asked is, what is the most persistent entity around here? And this is in a world where the building block of fraud detection was the transaction, but the transaction is transient, right? What we found that the persona is the most persistent entity around. And what we mean by persistent is persistent by reputation. That is, most of the fraudsters will stay fraudsters, and if they are doing a legitimate transaction, I don't care to decline them. Most of the legitimate people will stay legit, right? So we built our data stores around the personas, about around the people, and the people and everything that a person needs in order to act online is what we maintain by this data stream. And we do it continuously in real time. We collect everything that happens in real time, update this graph of personas and everything that they need in order to act online. They need a device, they need a connection to the internet, they need to give us contact details, they sometimes need an account, and they need a payment method, right? And all of these are updated in real time. And this updating is actually feeding the models. It's not that we can retrain all the time, but a lot of the reputations and the entries into the machine learning models are updated in close to real time. Close to real time, we're talking seconds from the event arriving at our gates. So there is this stream of data that gets into our system continuously. This stream of data updates everything we know about the reputation and other attributes of the personas that we work with, and about everything else around them. Just as an example, the reputation, of course, is the most obvious um, attribute that you would like to update about a person. But let's think about an IP. Is this IP a mobile IP, or is it a residential access point? Now, this is a simple question, and this simple question, our inference about a particular IP can be updated through new data. And this may have tremendous impact on our ability to use this IP for matching entities. Well, if both of these IPs, the IP for particular persona and the IP in the incoming transaction, are the same, and we know that this is a residential access point, well, this really increases the chances that this is the same person, or at least these people know each other, and we can infer and project reputation from one on the other. On the other hand, it could be that this is a mobile IP, and these two people have no idea about each other, they're simply sitting in the same train and enjoying the same tower of cellular connection. So all the data that is streamlined into our system in real time continuously updates our belief system, our understanding of the world, and the attributes of all the graph of entities that we hold. This graph is the base of the way we represent the world. So in time of asking the questions, when we need to take a decision, all what is left for us to do is to take all this graph of entities, to take the data from the incoming transaction and apply the machine learning for the fraud, given all what we know about this person now that is composed of this transaction and all the personas that are connected to this transaction, and take the decision. This actually enables us in real time to take decision not only on fraud transaction, but also on anything that a merchant or our customer can ask us. So some of them are asking us whether during login to apply 2FA on two-factor authentication on this person. A big hotel chain is asking us whether to enable a person to go directly to the room or force them to go to through reception, and so on. We can answer not only payment transaction, but we can tell about the reputation of the person in any other point in their journey through the website of our customer.
Yeah, definitely. And great insight. And I wanted to say thank you so much, Iftah, for joining us on the show today. To our audience, for more information on the data standard, you can find us at www.datastandard.io, as well as on our LinkedIn and YouTube channel. And thank you so much for joining us, Iftah. It was such a pleasure to have you today.
Thank you very much for having me.